So over here, I'm going to do the long division. You do not need to write this down. It is more for, again, understanding what's going on. I'm going to take 2x squared minus 23x plus 63, and I would like to divide x minus 7 into it. The key to synthetic division, this part you do need to make sure you have, is that this x is actually x and not 2x, not 3x, not 5x, but 1x. If it is not 1x, we'll resolve it. Now the difference is how we set it up. So synthetic division, you might recall, and there's a couple ways you can find it online. So there's a couple different setups. This is the setup that I was taught. This is the setup that I use. You have to understand advanced algebra with translations and scale changes is always about the opposite, x minus h. Since this is x minus 7, we actually put 7 into this spot right here. So remember, this number is the opposite of the number that's in this spot. When you do long division, you don't look at the 7, you look at the result. In synthetic division, it's about the 7. I'm going to show you why they actually are the same thing. And it comes down to the process. When you do long division, you figure out how many times does 2x squared get divided by x? Or 1x if you want to be more specific. And you find out that 1 goes into 2 twice, and x goes into x squared, well, x times. The beauty about synthetic division is we ignore all the x's and we focus on the extra pieces. Let me demonstrate. When you go do this next step and you go 2x and then you actually multiply it to x minus 7. So yes, we ignored the negative 7 at first. And we'll write 2x squared here. The whole reason we put this number here is so that this will cancel out. And we know it's going to cancel out because we're going to force it to cancel out. What we really are interested in is what happens when you go 2x times negative 7 and you get negative 14x. Okay? But then as we know, we actually have to subtract this quantity. Well, what happens with synthetic division? Well, first, you have to write out all the coefficients without x's. So start with the largest degree term and put 2. Then put negative 23, and in the last column, put your constant 63. Okay? Now, you want to end with the constant, and if it ends with an x and you have a whole bunch of x's, you should be factoring out that x first and then doing your long dividing. Okay? That's really what you should be doing. The reason we're not going to spend any effort on this is because this is a 1x. We know that this has to be 2, just like this 2 is right here. What we're interested in is this result because it sets us up for the next number. Now, the trick is you're going to say, well, wait, that's a positive 7. That's right. This is a negative 7. But think about this. Subtracting a polynomial is kind of challenging if you keep forgetting that you're supposed to distribute. We always said instead of subtracting, how about we add the opposite? Well, the plus 7 does exactly that. We go 2 times 7 and we get the same 14 as we get it right here. And then we add. That's why synthetic division works. It already takes into account that we will want to add the opposite. And by having the opposite number here, that's in fact exactly what we're going to do. And so now we'll have negative 9x. I already know this has to be negative 9. I'm going to take negative 9x and I'm going to divide it by 1x because it's always divided by 1. It's going to have to be negative 9. That's what that number's there. I don't care then. It's already kind of done in synthetic. I need to understand that negative 9 times negative 7 is positive 63. Give me a second here. Because I put that there, I kind of didn't bring this down. And I wanted to write negative 9x here, and then I wanted to write positive 63 here. So let me be clear here. The negative 9x is because of this work right there. The 63 here is because I dropped it down. Okay? The negative 9x here is from negative 9 times 1x, which is right there, and the negative 9 times negative 7 is the 63 here. Well, guess what I do? I go 7 times negative 9, I get negative 63. And what happens when you subtract a positive from a positive? It's the same as adding the opposite. And look at the math. 63 plus negative 63 works out to be 0. That's how synthetic division works. These numbers correspond to the numbers here. And so this goes to x to the 0, which we just simply write as negative 9. This goes x to the, I want that in yellow. This is x to the first. Well, let's be clear here. That would just be 2x. And then you just keep going up. This is your remainder. How to put it back here? Okay. You know how this is supposed to be 2x squared? Here, I was trying to put this in green. This is actually 2x squared, x, and then this is your constant, basically quadratic linear. Everything shifts over. So literally, this should become x. This becomes your constant. It's all 1 degree less. So I'm going to tell you right now, if this was a cubic here, this should start off as a quadratic down here and work your way. And then this should always have one extra piece, and that will be your remainder. And here's the key. When your remainder equals 0, then x minus 7, which in this case the remainder is a factor. So the answer to this question is yes, it is a factor. In fact, you actually know 2 factors. Not only do you know that x minus 7 is a factor, but your result is actually a factor as well, because x minus 7 times 2x minus 9. It's like saying, if 72 divided by 8 works out to be nicely as 9, well, 9's a factor, and so is 8 is a factor. Was the one that you were dividing by, was your divisor a factor? And the answer in this case is yes. If this number is anything but 0, then the answer is no.